So good morning to everyone, and thank you very much for joining. Today I will be sharing our work on two projects called EMIA and IMMERSE, focusing on advanced AI and computer vision for urban digital twins. So just a brief introduction about our company. What we do is basically delivering custom AI solutions, and our R&D focuses in any type of AI technologies and computer vision, especially on smart cities and industrial applications. And actually, the work that we're going to present today, and hopefully it would be useful for digital twin application, is also based on two of our patents on data anonymization and detecting anomalies in a system. Myself, just a very brief, I work as a researcher for Interactive Coventry for over 10 years, and I specialize in applied AI technologies. Next slide. So why we need smarter technologies and digital twins? The first is very common knowledge. Basically, cities face rapid urbanization and congestion, and there are climate-driven hazards that disrupt mobility and safety. Fair enough. I need to say here that maybe 10 years ago, I was trying to put together some research proposals on detecting floods. And you can understand that someone may look for some regions that are affected and the impact that this phenomena has. And actually what I was finding very severe cases, but in very specific regions. Nowadays, when I try to do the same for a research paper, I have to say that I found this phenomena happening more and more often and in areas that wasn't expected. For example, I have seen very recently in Turkey, in Italy, even in the Middle East. So we need a resilient system to deal with this. And maybe one of the core aspects and the core things that this type of system needs is data. And the data will come from the existing sensory networks. And for us, that we use mainly computer vision from the cameras. However, if we rely only on CCTV systems, these are static and often blind, if you think about it, if there is no CCTV covering a specific area of the city. And of course, in this type of applications, there are severe data privacy and GDPR concerns. So what we need at the end of the day for a good digital twin or in general smart city monitoring system to be resilient, so to operate under difficult conditions. Actually, someone may claim that this is when they need it the most, to be low cost. So this can be used by any type of country. Actually, some developing countries are suffering from this phenomena, and of course to abide and respect the privacy regulations. So this led us to the next slide, and our first example project was called EMIA, basically a smart monitoring system that was developed in partnership with a Singaporean company called City Matrix. And the pilot tests and deployments were done very, very limited in the UK, mainly for development purposes. And in Singapore was the main pilot test happening in March 2024 and February 2025, basically in an area behind the Singaporean docks. Because actually what happened there is that we had access to many different data from the city. And also this area was subject to flood. So it was the perfect pilot area. So in the next slide, the main technologies and innovation that was included in this system is that we had an AI layer. So what was happening there is that it was able to get data from cameras, from CCTV, from weather apps, from open city data, like, for example, how many people were on a bus stop. And all these things were processed through AI models to provide either what was detected or forecast. So basically, you can combine some information together, like, for example, imagine that you know the weather, you know the people that exist on the bus stop. Maybe this can help you to forecast how many people will be in the bus stop in the future. For this, we also use some custom cameras that we used in previous projects, dust cameras. We developed separate computer vision modules for everything that we wanted to monitor. So for traffic, for road surface, so if it was raining, how this affected the road, for pedestrians, for anomaly recognition, which is in this context, we meant basically if there was an accident, if there were roadworks in the area. So all this information that were captured, either captured or forecasted, this was transmitted to the VR environment of our partners. So all these informations were replicated in VR. So we had a view of the area of deployment. And of course, built in the system, and I think it's useful for every system, was anonymization of faces and plates, and we always ensured that all the measures were in place, cybersecurity protocols between data transfer between us and our partners. So a very short video in the next slide concerning our part of the system. So basically what was transmitted, what was transmitted to our partners, basically. So we can choose where we had some locations with our data sources, retrieve this stream, and out of this stream we were able to extract all kinds of information, identify the road condition, see if there was any accident there or any roadwork, incorporate the weather information, use all that to do forecast on the signals that we were interested in, mainly how many people, how many vehicles would be in the scene. We could switch, obviously, between different sources to get the information that we need. And finally, what was also going to happen is update the entire overview. So to retrieve all this info for all the city to monitor the main things that we want, which in this case was the pedestrian and the traffic density. Imagine that all this info and only this info were transmitted to our partners VR. So they were managed to replicate and show this in the VR environment. The same exactly principles happen with the dash cameras. So through them, we could also do the operations that we did through the static CCTV systems, like you can see here. So identify these different elements, record the statistics, and transmit them to our partners. If we go to the next slide, so what we can keep from this. First, if we rely to these mobile data sources, there is a lower cost for monitoring the city, and also because we don't need so big installation and maintenance cost. If we use combination of signals to do some forecasting, so imagine that we, in order to forecast the traffic, we take into account the road accidents and the weather, for example. This can provide better accuracy. In these applications for digital twins, for smart city monitoring, having strong data protection is crucial. This is realized, for example, here through the real-time anonymization, but also if you only transmit the results of the models. So if you just say that there are 3 people there, 5 vehicles, it's different than transmitting the actual stream. Hopefully, through the interfaces, both through the web and the VR of our partners, we can provide a clear view of the city. And since this is a clearly modular approach, someone can add or remove modules in wheel. So if someone is interested more, for example, in traffic, it can keep the traffic modules. If someone is interested in monitoring pedestrian movements, he can focus on that. So again, this is very scalable and modular model. So this led to the second project, which was a natural continuation called Immerse. I have to say this was one of the projects that was directly implemented based on user needs. So we got the feedback that when some disasters are happening, this system needs to continue to operate. And actually, when disasters happen, this is the time when networks are down or all bad things are happening in the same time. The second that we got is that during this time, they needed some decision support. A third thing is that if you can imagine, one of the core advantages of the technology that we are showing is that you are able to transform basically every stream to a data collection device. So there is some kind of trade-off between using this data to make your models more intelligent, but at the same time, respecting privacy. And finally, there was a need to support drone operation. This was especially true in Malaysia, where they had some areas where when flood was happening, basically they were inaccessible. So they can do anything to support the people or monitor the situation. So this led us to immerse technology, which in the next slide we can see the main technology. The natural thing to do was to include drones in the vision analytics. We incorporated two crucial techniques called federated transfer learning to help the AI models learn locally and adapt to new cities. This we can expand a bit later during the Q&A. I think this is one of the crucial parts. We have to say that we moved away from VR to AR this time. The reason is that when a disaster happening and the operators needs to react quickly, it's good to have connection with the actual environment next to them. We incorporated some computer vision modules for hazard detection. So like we said before, you can have a computer vision module for everything that you want to detect. This time we were interested in disasters, so we incorporated for fire, for floods, for accidents. We also included scene understanding, and we included some operations to support the drones, mainly to draw a safe route and where to land, because if you want to drop supplies or to land with some supplies, you need to find a good place to land, especially if something bad is going on. Something very simple that we did, but it was very important, is that if the network is down, we included a very simple module to switch to a satellite-based network. So if the core network is down, the operation continues. Again, the whole system is in the context because it's a work in progress to build in commercial equipment, but with options to include different modules. So a very simple video for our current work. In the next slide, please consider that this is actually the start of the project. So someone can see, for example, the available data sources and run the analysis to see if something bad is happening. And let's say that the flood is detected. Obviously, this is not, no flood happened in Coventry. This is just simulated data. So what happened was that the computer vision was detected, let's say, a serious flood. This in combination with the other modules, imagine that you have something saying to you that there is a flood there, there are 5 people there, there are 10 vehicles there, the road is blocked. So all this can be combined, so you can provide some support to the people making the decisions. And also we have included some modules to support, for example, the landing and the operations of the drones, with main 2 problems being addressed based on what we were getting from the people operating them. The first was to find a safe place to land, like we discussed. And the second is that because you have many drones going in and out, to have some kind of module to detect other drones, so it's able to avoid them. So if we consider this system as well, what we are going to get in the first slide as advantages for this technology is that the first, if you can move, Daniel, to the next one, is that the AR can help planners to act faster. The federated learning approach, which is basically that an edge node at the edge, the camera, or a laptop at the edge, can update the model weights based on the data that is incoming and then transmit only the model weights to a central node, and all the edge nodes contributing to make the model more intelligent while not transmitting raw data. This is maybe a key point that supports developing more intelligent AI, but at the same time respecting regulation. Having a satellite fallback always help to the system to be more resilient. Using commercial equipment or any type of visual capture equipment lowers costs. Transfer learning is very important to tailor the system to a new city quickly. Main problem that someone faces, you need to build a new system, you need to go there, install the equipment, collect data, then train the models. Why not having some general models trained on, for example, detecting vehicles, and then use the already trained models with some very limited data to optimize it for the area of deployment. And finally,
1 minute left, if you may.
Yeah. Yes. And finally, the core aspect, since only results and forecasts are transmitted, the requirements are low, which also helps during crisis situations. And finally, for the last slide, that we can also discuss in more detail during the discussion, direct application of these digital twins for critical infrastructure, for industry. Every device can be data collection, so why not citizen participatory sensor, explainable AI and the generative AI. Always good to see, since you know this information, how maybe an AI reaches a decision. And finally, the application of quantum machine learning, maybe to support the processing of all this data or simulations in the digital twin. Thank you very much. Sorry for going a bit over the time. I kind of accelerated at the end to save it. I hope this was okay. And thank you very much for your attention.
So first question here is, how do you handle the trade-off between anonymizing sensitive data in real time and maintaining temporal consistency in digital twins, especially for applications like crowdflow or occupancy prediction?
I think the main thing is that what we are setting our priorities to be. To be honest, for this, we just couldn't get around the anonymization aspect. So what happened is that we were processing the real-time video and images through our algorithm, and we were getting the anonymized, let's say, stream, and then any processing was done to extract the information. So in a sense, if you can imagine for us, we have said that it was first priority to keep the data, let's say, secure, both from the perspective of anonymizing them, but also from the perspective of extracting what we needed and then transmitting to our partners to replicate, because we felt that sometimes it was more important, for example, if this happened in a matter of, let's say, it was not achieved real time, but we felt that the delay that was caused, that was very, very close to the real time, really didn't matter for us if the same, when the same thing, was detected just a few seconds ago and was replicated some moments later. So for us, it was not crucial from the perspective of the application, but this happened a bit, with a minor delay. However, this is very important, and thank you for the question, it's excellent. In one of the application areas that we showed at the end, where in the industrial, for example, setting, for example, some applications like detecting the faults in a specific object or doing some other operations, so it's very critical to have very low time requirements, and for that we try to be very fast. And actually, we're currently working also with a project where our academic partners are looking at the aspect of supporting the network behind these operations in order to support this type of applications.
Brilliant, thank you. Our next question, if I could please, is who owns the risks if something is not detected by the AI? It would be interesting to know what human interventions are needed, if any, to make sure nothing critical is missed.
Yeah, again, another excellent question, which also allows for a lot of feedback. Yeah, we can do, no AI is perfect. Always we will miss some things. But I can tell you one thing that we are doing, and I think it's a good idea for any type of system, is that when something is let's say misclassified or missed, or even you identify, it's also the opposite, all right? You can also detect something that is not there. So you can always allow for the operator to provide direct feedback, and this feedback can feed back into the AI mechanism itself. If you look at this is a process, it also has a very good reinforcement learning, when your algorithms can continue to be improved and become better by allowing the human operator to provide this feedback. And actually, if you think about it, this feedback is also super important. If you think for any AI, one of the most important aspects, right, it's to provide very good data. And this very good data, imagine that we're referring only to samples that the AI may got wrong, so or have rich information for the context of the application. Then if you allow this human in the loop, let's say, to happen and support that helping through the AI to become better, I think this is a good idea. Understandably, every AI can be wrong. You can always lose some things. Hopefully, by time it's becoming better. However, it's good to have some mechanisms to address that.
Thank you. Another question here, please, is what process did you use to capture and articulate the information requirements of the project?
Look, for the Immerse project, which is it's simply, we only use video data. For the other one, we also used even data from weather apps to get some up from there. We used with API to get some data that were available from Singapore to see the number of people in buses and bus stops, even taxis. They had all this type of information available, which we could use in combination with our sources. For the new one, it's completely visual. So we have basically three sources: CCTV, dash camera, and drones, going around capturing the video. The video is processed, and this is how this is happening. For the previous project, imagine that when the information were extracted, so the video was passed through the computer vision, someone could detect the things that they wanted to detect. So, for example, how many people, how many vehicles. If there is an accident, how is the road surface? Imagine this was just a numerical values, all right? It was not. So this is what was transmitted to our partners. It was saved in a database, I think, and it was extracted, and they used that in order to create the application.
Very good. Thank you. I think we have probably a chance for one more question. We'll try to do both. Is there a specific benefit on your project for using VR over other types of 3D visualization?
Yeah, we consider for the first project the virtual. You can see that we're not. It's not like we consider that VR is somehow a one-way street or the only way to go. And maybe maybe for example, what you have seen in the first project where our partners did the VR, someone could argue why even have 3D representation if you can show all the information that someone needs through the dashboard. I guess it's always more immersive, or you can include more things, and you can have all the benefits from the digital twin technology. Imagine for the Immerse, for example, we also switched to AR. And we switched to AR for a very specific reason, that being very immersed in the VR, maybe it was not so good for the operators or for the people making the decisions. So for me, it's not like, that it's a decision should just be based on, yes, we need to use VR or something. No, I think based on the application or on the needs, even from the needs from the stakeholder or the client, you can decide to go other ways as well. I think the main thing is that you should be able to convey the information that they need in a nice way, in a way that fits their needs.
Very good. And our final question, if I could here, please, is a lot of the demonstration focused on looking through different camera feeds and maps. Did you design the user experience, UX, in this way, or are there similar ways the system can support the end user?
Yeah, I have to say that what was shown today for us, imagine that this is what we have developed mainly to support our backend and see what we were getting. The main interface for the first was the VR, and for the second, is under the development, right? So, yeah, I'm sure that there can be very, very efficient ways to show this in a more nice way. Just want to use this comment also to say something. That we believe that, and I think maybe this will be the truth in the future, that any interface would be supported by generative AI in the future. So imagine that you are getting this information and you pass it to generative AI. I'm sure that this could lead to a more user-friendly interface, with someone may be able to interact in natural language very, very quickly, very, very easily with it. Ask it what is happening there. The generative AI could reply that I have seen that there are this and this and this many people and this type of event, and based on your policies, I suggest you respond like this. So I really strongly believe that incorporating Gen AI in these interfaces would improve a lot, let's put it that way, these applications. No matter, how the visual aspect with the maps, and I think this would be a major improvement forward.